Hello, in this video we're going to be going through a whole practice paper for the National 4 Relationships unit. Okay, so here is question 1 and it's in two parts. The first part says complete the table below for y equals 2x plus 1. So we need to fill in these y values and how do we do that? Well, we've got this equation to help us. The y value is equal to 2 times the x value plus 1. So that's all I need to do. I'm going to take my x value and I'm going to multiply by 2 and then I'm going to add 1. So if we do that here, that means in this first box I'm going to have to do 2 times 1 plus 1, and that's going to be 3. And then I'm going to have 2 times 2 plus 1, so that's 5. And then 2 times 3 plus 1, that's 7. And now, now that I've got some x values and some y values, I can turn each of these into a pair of coordinates. So this is the coordinate 1, 3, the coordinate 2, 5, and the coordinate 3, 7. So the x1 obviously goes along the x-axis, the y1 goes along the y-axis. So this first point that I'm going to plot, because that's what it says to do in part B, by the way. So we're going to draw the line, and we're going to do that by plotting these points. I'm going to plot the point 1, 3. So it's 1 on the x-axis, 3 on the y-axis. So that's going to be 1, 3. So there is where I need to put my point. 1, 3, there we go, about there. 2, 5 is the next one. So that's 2 across and 5 up. That's about there. And 3 across and 7 up is there. There we go. So what it's asked us to do is draw the line. So it's not just plotting points. We need to draw the line. So I'm going to have to, if you're doing this on your page, you'd use a ruler to go through these points. I'm going to use my straight line tool here, and we've got, close enough, there we go, a straight line going through all 3 of those points. And it doesn't just start at the first point and end at the last point, it goes sort of the whole way across the graph like that. And we should also, since we've been asked to draw the line y equals 2x plus 1, we should label our line as y equals 2x plus 1. There we go. Okay, that's question 1 sorted. Question 2 is another one about straight lines and graphs. We've got line CD is shown on the grid below. Write down the equation of line CD. Now this is a nice simple one. We just need to remember if we've got a horizontal line, what does the name of or the equation rather, of a horizontal line look like? Well, we need to know which axis it's hitting and where it's hitting it. So it's hitting the y-axis. We can see that because there's a y up here. And it's hitting it at, well, if this is 5 and this is 0, that's got to be 2, right? So the equation of this line is the line y equals 2, because it hits the y-axis at 2. Good. Next question then, question 3. Solve the following equation. So we've got 3y plus 7 equals negative 14. So we're saying 3 times something plus 7 gives us the answer negative 14. So we're going to have to work out what that something was. What's the y that we started with? And the first thing we're going to want to do is to take away this plus 7. So we're going to do the opposite of adding 7, and the opposite of adding 7 is subtracting 7. And because I've subtracted 7 from the left, I better do the same thing from the right, otherwise they're not going to be equal anymore. So if we do that, we're going to be left with 3y. I had a 7, but I've taken it away, so it's just 3y on the left. And on the right, I was at negative 14, but I've taken away 7, so if I'm taking away 7, I'm getting more negative, right? If I'm at negative 14, take away 7, it's going to be an even more negative number. It's going to be negative 21 in this case. Final step then, 3y's is equal to negative 21, but I want to know what 1y is. So 1y is, well, if I know 3 of them and I want to know just one of them, we're dividing then by 3, aren't we? So we divide by 3 on the left. We better do the same on the right. There we go. We've got negative 21 divided by 3. That's going to be, well, 21 divided by 3 is 7. So negative 21 divided by 3 is negative 7. There we go, there's my answer. Y equals negative 7. And it's going to be important that we write out all of our working like that as well. We don't just want to jump straight to an answer. We want to see that method. Okay, question 4. To find the distance of a journey, we use the formula d equals st, so that's distance equals speed multiplied by time. Change the subject of the formula to t, so we need to make t the subject, this guy here. At the moment d is the subject, right, because d is on its own on one side of the equals sign, and we want to make t the subject, so we want to get rid of this s. Now we need to think carefully about what this means. So far I've got d equals st, and when we've got two variables next to each other like this without a symbol in between, it means that we are multiplying them, right? There's a sort of an invisible multiply sign that we don't bother writing. We just write it like that, d equals st. So if I want to get rid of this s and leave t on its own as the subject, we're going to have to do the opposite of multiplying by s, and the opposite of multiplying by s is dividing by s. So if we divide by s on this side, we're going to do the same on this side. We're going to divide by s, and I'm going to choose to write it like this. I'm going to write d over s. You could write it with a divide sign, but this is a slightly tidier way of writing it. D divided by s is equal to, and we've divided by s on this side, so that s is gone now. We've just got a t. Now we could leave it here, but normally when we change the subject of a formula, we want to put we want to put the new subject on the left-hand side. So instead of saying d over s equals t, I'm going to write exactly the same thing, just swapping everything around. I'm going to write t equals d over s, just because that's a slightly more conventional way of leaving our answer. We want the new subject on the left rather than on the right. Okay, good. We'll do another one, question 5. Now we're changing the subject again. This time we've got a slightly more complicated formula. We want to make b the subject. So this is going to be our new subject. We want to get rid of this multiply by 7, and we want to get rid of this plus 2, but the plus 2 is the bit we're going to get rid of first. So in fact, maybe I'm going to write this equation out. Just got a bit more space around it. There we go. First thing I'm going to do is get rid of this 2. So I take away 2 from the right. I'm going to have to take away 2 from the left as well. So I've got an a, I'm taking away 2, so that is a take away 2. And that's going to be equal to, well, I had 7b and a 2, but I've taken away the 2, so now I've just got 7b. 7b, good. Now I want to make b the subject, so I don't want 7 b's. I'm going to get rid of this 7. How do I get rid of 7 multiplied by b? I'm going to divide by that 7. Divide by 7 on the right, divide by 7 on the left. And again, I'm going to write this on the left as a minus 2 over 7, like that. And that's going to equal b on the right-hand side. I'm going to do that same final step that I did on the previous question. I'm going to swap these over. So we've got b on the left-hand side is equal to a minus 2 over 7 on the right-hand side. And there's my answer. I've made b the subject. It's equal to a minus 2 divided by 7. Okay, we're on to question 6. We've got triangle ABC is a right-angled triangle, as shown in the diagram below. AB is 5 meters long, this bit here. AC is 13 meters long. Calculate the length of BC in meters. Now we're going to need to remember Pythagoras' theorem here. And Pythagoras' theorem said that if I've got A, B, C, where A is the longest side, remember we call that the hypotenuse, that A squared equals B squared plus C squared. Now because we are trying to find one of the shorter sides, a slightly more useful version of the formula is going to be that A squared minus B squared is equal to C squared. So we've got this A, and we're going to square it, so that's going to be 13 squared. We've got this B, it's 5, and we're going to square it. And that's going to tell us C squared. We can do 13 squared. Maybe we pop this in a calculator. Maybe we know that 13 squared is 169. 5 squared, again, maybe we pop it in a calculator. Maybe we know that 5 squared is 25. And we do that subtraction. It's going to be 144. So what that means is this C squared is equal to 144. So we've got C squared equals 144. C squared is equal to 144. C must be we need to unsquare it. We need to find the square root of that. The square root of 144 is 12. So our answer is 12 centimetres. The length of BC equals 12. Oh, I've got that wrong, haven't I? Not centimetres, we're in metres for this question. 12 metres. Make sure we check the question carefully for units. BC is 12 metres, there's my answer. Okay, we're looking at question 7. This one is asking us to draw an enlargement of the given shape using a scale factor of 5 halves. So what it means when it says a scale factor of 5 halves is we're going to need to halve all of these lengths and then multiply it by 5. That will be 5 halves, right? So first of all, let's check what these lengths are. This one is 4, and all the other lengths appear to be 2. So there's only 2 numbers that I need to find 5 halves of. The longest length is 4, all the short ones are 2. So let's find 5 halves. 5 halves of 4. Well, what's 1 half of 4? It's 2. And then I want 5 of those, so that's going to be 10. Let's find 5 halves of 2. Well, 1 half of 2, that's 1, obviously. And then I want 5 of those, so that's 5. Cool. So all of my lengths that were 4, I'm now going to make them 10. All of my lengths that were 2, I'm now going to make them 5. And let's see how accurately I can draw this shape over here. So this length down here was a 4, so I make it a 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's carry on going around this way. So this was a 2, I'm going to make it then a 5. 1, 2, 3, 4, 5. We're going to go along 2, up 2. So instead that's along 5, up 5. So I'll trace it with my sort of pointer first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're joining up to here. 1, 2, 3, 4, 5 up. We've got 1, 2, 3, 4, 5 along here. 1, 2, 3, 4, 5 down here. And the final one is a nice diagonal up there. Now, I suggest that when you do this, you use a ruler because my one is a big old mess. So yeah, let's make sure we use a ruler and get this nice and neat when we draw that enlargement. Question 8. In the diagram below, lines PQ and RS are parallel. Lines BA and BC, intersect PQ and RS at the points D, E, F and G as shown. Angle CEQ is 63 degrees, CEQ, 63 degrees. Angle RGB, is 123 degrees. Oh, that says 123, this one says 121. Let's pick one, shall we? Let's go 1, 2, 3. So I'm going to change this one in the diagram to 1, 2, 3. Apologies for that, guys. So, calculate the size of angle ABC is what the question is asking us to do. So first of all, let's find angle ABC. So we've got A, B, C. It's this one here. It's already marked for us. I'm going to just remark it again in orange so we definitely know which one we're looking for. Okay, good. So what do we know? What can we work out? Well, we've got a big old triangle here. Maybe that's going to help us. We've also got some parallel lines. I'm sure that's going to help us too. Let's look at what we can find. So initially, I'm not sure exactly how we're going to find this angle, but let's work out what we can find straight away. So if this is 63 and these guys are parallel, then this is going to be the same as this because they are corresponding angles. So this is also 63 degrees. What else have we got? It looks to me like, well, this has got to be a straight line. If this is 123 degrees, we can work out what this bit is on the inside of my triangle. Because we've got 123 degrees so far, a straight line is 180, so we can do 180, take away 123. Let's see what we get if we do that. We're going to need to do some borrowing. 10 take away 3 is 7, 7 take 2 is 5, 1 take 1 is nothing. We've got 57 degrees over there. We've also got, if this is 63 this one is vertically opposite, isn't it? And because it's vertically opposite, it's going to be the same. So this is also 63 degrees. So we've got this wee little triangle down here that has 1 angle of 57 degrees, 1 angle of 63 degrees, and a third angle which we want to find. So how are we going to do that? Well, let's do 57 plus 63. That's 10, carry the 1, 12, 120 degrees that we've got so far. So to get this last bit, we're going to have to do 180, take away 120, and the answer is going to be 60. So angle ABC equals 60 degrees. Good. Okay, question 9 then. PQ is the diameter of a circle. R is a point on the circumference of a circle. Angle PQR is 65 degrees. Calculate the size of the shaded angle QPR. So QPR is this one, right? Now, do we remember our fact about angles in a semicircle? If I've got this diameter, cutting my circle in two, then this angle up here at the circumference has to be a right angle. It's got to be 90 degrees. It always will be if we draw a triangle like this, which means that now we know two angles in our triangle. We know 65 and we know 90. So let's add those guys together to see what the last one's going to be. 90 plus 65, that's going to be 155 degrees. But the one that I want is this one. So I know this plus this needs to make 180. So let's do 180, take away what we've got so far, which is 155. And we're going to get 0 take away 5 I can't do, so we're going to do a little bit of borrowing. 10 take 5 is 5, 7 take 5 is 2, 1 take 1 is nothing, so we've got 25 degrees. 25 degrees is my final answer, so angle QPR equals 25 degrees. There's my last answer on that question. We'll go on to question 10. The end points of the line shown in the diagram have coordinates 2, 3 and 9, 8. Calculate the length of the line. Now this is another Pythagoras question, but it doesn't look like our previous Pythagoras question. We're going to need to do a little bit of thinking to find our right-angled triangle, because we know that is a straight line and that is a straight line, and we can find the lengths of those straight lines. So this one here is 1, 2, 3, 4, 5. And this one along the bottom is 1, 2, 3, 4, 5, 6, 7. So we've got 7 and we've got 5. And like before, we know that a squared equals b squared plus c squared, where a is the longest side, and here are my b and my c. So we're going to have to do a squared is equal to 7 squared plus 5 squared. And again, maybe we're using a calculator. Maybe we know that 7 squared is 49. Maybe we know that 5 squared is 25. When we add them together, maybe we know that that is 74. So a squared is equal to this. Ooh, that's a funny looking squared. A squared equals 74. Now if a squared is 74, a must be the square root of 74. And this is the point where we probably need to pop it in a calculator. Square root of 74, my calculator says, is 8.6023 and a bunch of other stuff. Let's round it to a sensible amount. Let's round it to one decimal place. 8.6 I'm going to go for. And there's no units in this question, right? We're not told what we're measuring in, so I'm just going to leave my answer as 8.6. No units to give on this one. We're on to question 11 then. Calculate the length of side x in the right-angled triangle below. So this is one of these trigonometry questions. So first thing to do in a trigonometry question, remember, is to label the sides. So which is the longest side? It's this one. Oh, it's this one, so that's my hypotenuse. What is this side x? Well, here's the angle that I'm interested in, so it's opposite that angle, so this must be the opposite. So which of my formula triangles is going to be useful this time? So we've got either so or ka or toa. So which one involves the opposite and the hypotenuse? Well, it's not this one. That one only involves the opposite. It's not this one. That one only involves the hypotenuse. So it must be this guy, opposite and hypotenuse. That's the one we want. That's the one we're going to use. This guy here. So sine. This is a sine type question. Sine. Good. So what are we looking for? We're looking for the opposite. So I'm going to cover that up in my triangle. Excuse me, sorry. Cover up the opposite in my triangle. Now I've got the S and the H are next to each other. Now when they're next to each other, that means I should multiply. So S, remember, stands for sine of the angle, so that's going to be sine of 65. I'm going to multiply it by H is the hypotenuse, so that's 10. So this is what I'm going to type into my calculator. Sine 65 multiplied by 10. And when I pop that in my calculator, I get 9.0630 and a bunch of other stuff. I'm going to round it sensibly to, let's say, 1 decimal place, 9.1. We're measuring in centimetres this time, and I'm going to say that I've rounded to 1 decimal place. Good. So there's my answer, 9.1 centimetres rounded to 1 decimal place. We'll look at question 12. Okay, question 12, the diagram shows a ramp which has been manufactured for a shop entrance. Calculate the size of angle x we've got first. Okay, so this slopey side is 7,200 millimetres. This vertical side is 830 millimetres. Here's the angle we're after. So labelling our sides first of all again. This is a hypotenuse. This side is opposite my angle. So once again, I've got an opposite, which means once again, the formula triangle I'm going to use here is SOH, S-O-H, because the hypotenuse and the opposite are the sides involved. Now that means sine of my angle, sine of, we're calling the angle x in this question, is equal to, let's cover it up in the formula triangle so we can see what I'm doing. Sine of my angle is equal to O over H, opposite over hypotenuse. So opposite over hypotenuse, and that is 830 over 7,200. So that's sine of my angle, but I want to get the angle out, so we're going to have to do inverse sine to this stuff, aren't we? So inverse sine of 830 over 7,200. I'm popping that in my calculator. So inverse sine of 830 over 7,200, and we've got 6.619 and a bunch of other stuff. Let's do a wee bit of rounding. I'm going to say that that's about 6.6 degrees rounded to 1 decimal place. So that's my answer to part A. Part B says, for the ramp to be safe for wheelchair users, the angle x should be between 5 and 7 degrees. Is this ramp suitable for wheelchair users? Brackets, justify your answer. Okay, so if I were to just say yes, I'm not going to get the marks there because I need to justify my answer. So how am I justifying my answer? Well, because I've worked out this angle, it's 6.6 degrees, and that is between 5 and 7. So we need to say that last bit. Yes, because something along the lines of 6.6 degrees is between 5 degrees and 7 degrees. Okay, we're on to question 13, and this is the last one. We've got one of those scatter graphs. So, the following table shows the speed of a car accelerating from rest. So we've got time and we've got speed. And part A is asking us to draw a scatter graph of the information onto this grid. So at time 0 seconds, the car was going at a speed of 0 miles per hour. That makes sense. So 0, 0, that's over here. Try that one more time, get it right on the point. There we go. 2:10, So at a time of 2 seconds, that's going to be here, we are at a speed of 10. So that's going to be about there. So my point is going to go about there. At a time of 6 seconds, so that's going to be about here, we're at a speed of 50. So that's going to go there. 6 and 50. There we go. 8 and 60 is the next one. So 8 and 60 looks like it's about there. There we go. We've got 12 and 80. 12 and 80 is about here. And we've got 16 and 110 is over here. Good. Now part B says draw the best fitting line on the graph. So a line of best fit going through, or at least going near to as many of these points as we can. I reckon we're going to have a line that looks a bit like, a bit like that. If you've got as many points above your line as you do below your line, then you know you've drawn a pretty decent line of best fit. So I've got 1, 2, 3 below, and I've got 1, 2, 3 above, so that'll do. C, use your graph to estimate the speed after 10 seconds. Okay, so we've got this line of best fit that we can use. I'm going to go and find, right, 10 seconds is here. So let's draw a line going straight up from 10 seconds until it hits my line of best fit, and then go straight across to find the speed. So I reckon that's somewhere in between 60 and 80. It's a little bit more than 70. I'm going to estimate that that's about 71 miles per hour. Good. Now we need to do part D, the last part. A car travelling at a speed of 70 miles an hour was estimated to have been accelerating for 10 seconds. Is this a reasonable estimate? Well, it's sort of the same as this question, but backwards, isn't it? If our car is travelling at 70 miles an hour, 70 miles an hour is here. Ooh, a little bit too high. 70 miles an hour is about here. There we go. We hit our line of best fit. We come back down again. It's, yeah, maybe it's slightly less than 10 seconds, but that's a pretty good estimate, isn't it? We're not trying to be super accurate here. Yes, this is a reasonable estimate. And the working that we need to show for this question is just like that orange line that I've drawn over here. We've shown that if I go from 70 over to the line of best fit, back down to the time axis, about 10 seconds. Yeah, that sounds good to me. Okay, that's us done there. Cheers, I'll see you in a bit. Bye.